Hi guys, I'm making this video because there's been a lot of controversy and debate about the March 12th, March 13th Magnetopause event that occurred just a few months ago. As some of you may know, our research team has been doing extensive research into trying to figure out, number one, what, if anything, happened, and try to provide some sort of explanation. To be honest, it may be something that can't be explained, not with our current knowledge. And I also want to clear up a few pieces of information about the event. There are some research groups that are associating this with a heavy mass object coming from Leo, and I want to show you why I believe that is not the case. And let's look at a few possibilities first. Number one, the official explanation was correct, that it was bad data in, bad data out, there was nothing to see. But that still leaves a lot of questions. The data does seem to be every aspect of the data, and we're not talking just about these simulated plots, but even the raw data that we see. The fact that the legends kept rolling during the event. The hastily removal of data off the NICT while it remained on SWMF for a brief period of time. A lot of those data sources, or some of them, are still not available and probably will never be. But as you know, a lot of us did capture the data. I want to point out a few things, and then I want to show you some images and charts that I have made using Stellarium. I'm going to back this up a bit. This is one of many many videos. I'm going to start playing this. This is before the reversal. This is the Y-cut, BATSRUS simulation. I think this is only playing at 1 or 2 frames a second, so I may speed it up from time to time. The reversal's taking place now. Look at the magnetic field lines. Now the argument has been, let me go back just a second. Couple frames. Let me pause it. Where you see these red lines are closed loops. These are open magnetic field lines. Now one of the arguments has been that on the 12th that the Earth was directly positioned between Sun, Earth, and the constellation Leo. Well, I'll show in a few moments that that was not the case. And the other argument was that this anomaly that lasted 28 hours came from right on the ecliptic, from exactly 180 degrees in opposition, meaning like if you look on this graph at this 0 degree mark, that everything flowed from, just to keep it simple, from left to right, from west to east, just looking at this plot. And that's not the case either if you really study what happened. Initially, when the event first started, yeah, everything seemed to be coming from a direct blow 180 degrees behind on the ecliptic. as it gets going, you're going to notice both these closed red loop lines and the black ones have a tendency to go upward. I'm going to guess at around, I'm just judging, maybe somewhere between 20-25 degrees shy of the 180 degrees, which would be a straight line from left to right. Again, the sun would be right here on the right side, indicated by the half white, half black circle, which is Earth, and the black being night side. I'm going to let this play a little bit, and you'll see the you'll see the changes in the magnetic field lines. Now things will get pretty crazy here in a minute, and you'll really start to get a bigger picture of the IMF lines. Now again, at times it does look like to be coming from directly behind, but now draw an imaginary line from the angle of the open lines and the closed loop lines and the IMF lines. Do you see this? Shy of this 180 degree imaginary line, horizontal line on the 0 point. If you were to draw a directional line from the source, it's about 20-25 degrees. I wish I could draw a line on top of this video to better illustrate that, but draw two imaginary lines, one across this chart, perfectly horizontal on the 0 mark, and think of that as the direction of the incoming anomaly. Well, that's not what we're seeing. Now simulation 2 here will show the Z-cut, and it'll show the flow lines. Now what this will illustrate is that it wasn't on the ecliptic, or these lines would stay perfectly straight. What you tend to see is it seems that the anomaly came from an upward angle anywhere between 20 and 30 degrees, which coincidentally also puts it in the neighborhood of our suspect, which was a gamma ray burst from the constellation Hercules, and I'll show that in a second too. This is when the reversal started. Now let it get into it and let everything kind of balance out, because this is a 28-hour event. Now watch these flow lines. Now they do shift around a bit, but they are showing a pattern of if this was on the ecliptic coming directly behind us, these lines would be straight. They wouldn't have a tendency to point up or down. It seems like the anomaly is far off, maybe 20 to 30 degrees above the ecliptic, and as it comes in, it's hitting us at a upward angle. So follow my mouse. Instead of it blowing directly horizontally this way towards the sun, it's more like it's coming from the right side about 20 degrees and above, I'm just going to guesstimate 20 to 30 degrees. So it would be more like this. Follow my mouse. So the source would be, say, really don't know the distance, but regardless of the distance, it seems to be at a upward angle. Now I'm going to stop this, and here is the gamma ray burst, GRB 120312A. It occurred at 1606 UTC, just minutes before the reversal started showing itself on the plots and on the simulations. Now, in contact with Fermi and people who work on the Swift and Fermi missions, magnetic and gravitational waves do accompany these gamma ray bursts. Now, while the gamma ray detections themselves only last up to 2 seconds, these waves can last longer, and they can precede or come after the gamma ray detection. In this case, it seems like a gravity or a magnetic anomaly or a wave was slightly ahead of the gamma ray emission itself. And of course, by the time the telescopes slewed to take a peek, there was a optical afterglow of 0. It's pretty hard to catch these things. From my understanding of the system, when these gamma ray bursts are detected, it's a pretty automated process. The telescopes are taken over by computer control. They automatically slew to where the burst was detected to try to catch the optical afterglow. And in this case, it was such a short event. By the time they focused in on it in the constellation of Hercules, again, just minutes before the reversal happened. This is why we think there was an accompanying gravitational or magnetic wave. Now, this is just one of our theories. Take it with a grain of salt. But now I want to get into some images that kind of support what you just seen on the simulations compared to the relative positions of the constellations on March 12th and 13th. This is in Stellarium. This is March 12th, 2012. Now I'm on the East Coast, so this would have been the Sun-Earth sky positions at the time of the reversal, which was about 1617 UTC. So we were about 4 hours behind. The sun I've got outlined here. Okay, so the question is, what would have been 180 degrees behind us, directly behind us? Slightly elevated, but directly behind us. Leo was directly behind us. The problem is, the source of the anomaly came from a altitude higher than Leo and several arc hours to the left of Leo, looking at it from this perspective. And we've seen that in the simulations and the magnetic flow lines and the magnetic field lines. We could see that it was coming in not from directly behind and not on the ecliptic, but slightly to the right and slightly above. Again, I'm just guesstimating around 20 degrees. This is where we think it came from. This was the source of the gamma ray burst minutes before the magnetopause anomaly. I've actually got Leo Minor circled here, but I should have circled Leo. This is, in some research groups, this is the proposed source. And I just shown you why we don't believe that to be true. This is the approximate geocentric position, or where the center of the Earth would be relative to this picture. Same date. What even led me to look in this area of the sky to begin with was I knew Saturn was almost in opposition and in alignment with the Earth and the Sun. So the Earth moving this way from right to left. This was a month and a few days shy of the Saturn opposition, so this is the correct position. Saturn moves much more slowly. It has a longer period. So by April 15th, which was the date of the Saturn opposition, Earth would have been directly here between Saturn and the Sun. And I've noted that right here. So when you look at these, when you look at the grid, okay, where's Hercules sit? Well, it's about 6.5 arc hours to the left of Leo. It is also another 10 to 15 degrees above Leo, which also supports the data that we saw in the simulations. And the next picture illustrates why Leo was not in any kind of direct alignment with the Earth and Sun on March 12th. The purple here is our ecliptic plane. The yellow disk is the galactic plane. They oppose each other at an angle of about 60 degrees. This is pointing to the galactic center in Sagittarius. And around the purple ecliptic disk, it's showing you the dates and the points of the solstices and the equinoxes. This would have been December 21st. This would have been March 20th. We would have been lined up with Virgo. Leo would have probably been sometime late January, early February. So we weren't in line. Sun, Earth, Leo, this line that I've drawn here, that would not have occurred on March 12th, because on March 20th, at exactly 1:14 a.m. Eastern Standard Time, this was the alignment, just shy of Virgo. The blue arrows represent the incoming anomaly, which again we think came from Hercules. OPA stands for Opposing Parallel Anomaly. It's just a term that we decided to coin to better explain, for lack of other better terms, what this anomaly was. We just call it an opposing parallel anomaly, or OPA. So going back and looking at the SWMF Y-cut and Z-cut simulations, you've seen the angles above and to the side, not a 180 degree on the ecliptic opposing force. This kind of better illustrates it. You can see that it's coming in at an angle, and I've guesstimated about 33 degrees above the ecliptic, not Leo, which would mean that this has nothing to do with an object in Leo. There is one more theory that makes a little bit more sense. Some of you may know that about a week and a half, 2 weeks ago, Fermi announced that on March 7th there was a very significant gamma ray event with our own sun. It lit up the gamma ray sky brighter than any other object visible to Swift or Fermi, and in gamma ray terms it lasted an eternity, 20 hours. It lit up the gamma ray sky, which got me to thinking, could this have been the culprit? Are we not looking at any type of gravitational, magnetic, superwave, anything related to a gamma ray burst? Could it have been a local event? Well, it came from the sun. You're saying, how could that possibly cause what we saw on March 12th and 13th? Well, I made a little animation that may describe a what I'm calling right now is just like a bounce back reflection Doppler type effect. What you'll see in the next animation is I'm depicting the gamma ray event leaving the sun on the 7th, lasting 20 hours. A shot over the bow, which is why we really didn't see any consequences from that event. So it barely misses Earth. 5.5 days later, after reflecting off of the heliopause, or the termination point, which it is debatable on how far out the sun's influence in the heliopause stops. We estimated it based on the speed of light and the time it would take to leave, reflect, and return would be about 69 billion miles. Right now, the agreed estimate of the distance to the from the sun to the heliopause is around 23 billion miles. But is there a termination point? Is there a bow shock? That's still up for debate. And could that be farther out? We also know that the heliopause is not a static environment. It does expand and contract, along with not only intergalactic medium coming in, but solar activity from within. So what you'll see in the next video is basically just a theory that I come up with that could explain how a local gamma ray event could come back to bite us in the butt. And I'll play that video now. Okay, this is the animation I made. I may need to back it up. Okay, it's already backed up. Now what this is going to depict is these are representing the gamma rays and the March 7th, 2012 solar gamma ray event, which lasted 12 hours. Again, Swift picked this up. It lit up the gamma ray sky for 20 hours, was the brightest thing in the gamma ray sky, and this information has just come out within the past 2 weeks. So I'll hit play and maybe you'll get an idea of what I am portraying here. The blue dot represents Earth. The rest of these planets are not, I repeat, are not in their correct positions. That wasn't the important thing. The important thing was just to illustrate the idea. The purple represents the heliopause. The red represents the bow shock of the heliopause. And I'll hit play now. So the gamma rays leave, make an estimated 69 billion mile trip. They're ionized, so they cannot escape the same way gamma rays cannot come in. They come back, they hit Earth, lasting 28 hours. Play that once more. Giving us our magnetopause opposing parallel anomaly. Again, this is just an idea, just a thesis. But I will say this, if you were to approach me with the data and what happened on March 12th, and you gave me several scenarios, I would have to pick the last scenario as being the most probable and the most plausible. Again, we never thought about this before because the data on the March 7th solar gamma ray event only came out about a week and a half, 2 weeks ago. Now, had we known this back in March, this would have been part of our equation the entire time, and it definitely would have been taken into consideration, because it does change the playing field significantly. But I know this was long-winded, but it kind of needed to be, just to kind of lay this out in the simplest terms possible. And as always, criticism, ideas, comments, other theories are welcome. And everybody take care. Thanks for listening.